Let us have a glance at the next question. The question goes like this. Which of the following has more unpaired d electrons? Zn plus, Fe2 plus, N minus 3, Cu plus. Look at the given ions. We have Zn plus, Fe2 plus, N3 minus, Cu plus. We need to find more number of unpaired d electrons. When you read the question like more number of unpaired d electrons, one of the options is ruled out. N minus 3 ion cannot have the d electrons. Now the options are restricted to Zn plus, Fe2 plus and Cu plus. We know the configuration of Zn. 3d10, 4s2 is the outermost configuration. When we have 3d10, there is no question of having unpaired electrons in 3d. Of course, it has one electron in 4s. Similarly, if you come to Cu plus, this has the configuration 3d10, 4s1. When copper is in plus 1 oxidation state, it loses that electron from 4s orbital, and this has 3d10 configuration, no unpaired d electrons in it. Now the remaining option is Fe2 plus. Fe2 plus configuration is argon configuration followed by 3d6. When it has 3d6 configuration, there are 4 unpaired d electrons in Fe2 plus. Look here again, Zn plus and Cu plus do not have unpaired d electrons. Both have 3d10 configuration. N minus 3 do not have d electrons, it has 2p6 configuration. Now the correct option is Fe2 plus. This Fe2 plus has 4 unpaired d electrons. So the correct option is option B. Now we'll move to the next question. The highest oxidation state is achieved by which of the following electronic configurations? Option A, N minus 1 d5 NS2, B, N minus 1 d5 NS1, N minus 1 d3 NS2 in option C, N minus 1 d8 NS2 in option D. From the knowledge of the oxidation state of transition metals or metal ions, we know that highest oxidation state is the number of electrons in 4s and the number of electrons in 3d up to N minus 1 d5 configuration. From N minus 1 d5 configuration onwards, we have the maximum oxidation state as number of electrons in 4s and number of unpaired electrons in 3d. As per this concept, look at the option A now. This is a d5 configuration. Maximum oxidation state is sum of these two. 5 plus 2, it can exhibit plus 7 oxidation state. Come to this, N minus 1 d5 NS1, 5 plus 1, it can exhibit plus 6 oxidation state. If you come to this, N minus 1 d3 NS2, this can exhibit 3 plus 2 plus 5 oxidation state. Whereas option D, N minus 1 d8 NS2 cannot exhibit 8 plus 2 plus 10 oxidation state, because maximum oxidation state is number of unpaired electrons in this plus the number of electrons in NS. So here we have, when D8 configuration is there, we have 2 unpaired electrons. Here and 2 electrons here, 2 plus 2, this can exhibit plus 4 oxidation state. So we have in the given options plus 7 here, plus 6 here, plus 5 here and plus 4 here. So the electronic configuration which has highest oxidation state is N minus 1 D 5 NS2. This can exhibit plus 7 oxidation state, the highest oxidation state amongst the given 4 options. Hence the correct option is option A. Let us move on to the next question. The question goes like this: which of the following atoms has biggest radius? Options are A. Titanium, B. Chromium, C. Iron, D. Nickel. We know that titanium, chromium, iron, nickel belong to same series, that is 3D series of transition elements. And we know the variation of atomic radius in 3D series. From scandium to chromium, atomic radius goes on decreasing. From chromium to copper, almost it remains constant. Slightly it increases in case of zinc. When you apply this concept here, titanium comes first, then we have chromium, then iron and nickel. From titanium to nickel, we have decrease of atomic radius. Of course, decrease from titanium to chromium, from chromium to iron and iron to nickel almost same. So therefore, titanium has highest atomic radius. This is one concept wherein you can arrive at the answer. Another thing is, these are in the same series. When you move from left to right in a period, atomic radius goes on decreasing. So in this period of 3D series, titanium comes first, nickel comes last before copper. Therefore, from titanium to nickel, atomic radius goes on decreasing. Therefore, titanium has highest atomic radius. So for this question, the correct option is option A, titanium. We'll move on to the next question. The question goes like this: which of the following ions is most likely to form colored compounds? Options are scandium 3 plus, copper plus, Zn2 plus, chromium 3 plus. My dear students, applying the concept is very, very important in taking up the questions of the competitive examinations. Time factor is also a major factor. Based on the time factor and application of the concept, you have to quickly arrive at the answer. Say for example, in this question, the simple concept involved is transition metals or metal ions with one or more unpaired electrons in d orbital form colored compounds. Look at this: scandium 3 plus is 3d0 configuration, copper plus is 3d10 configuration, Zn2 plus is 3d10 configuration. All these three options do not have unpaired electrons in d orbital. This is 0, this is 10, this is also 10. No unpaired electrons here. But if when you move to chromium 3 plus, this chromium 3 plus having 3d2 electronic configuration. Chromium configuration is 3d54s1. When it forms 3 plus, it loses 3 electrons. So chromium 3 plus is left with 3d2 electronic configuration. it has 2 unpaired electrons. So this forms colored compounds. So amongst the given transition metal ions, the metal ion which has 2 unpaired electrons in a d orbital, that is chromium 3 plus, can form colored compounds. So correct option is option D. We know the magnetic properties of transition metals or metal ions. In the introduction, I told you, if the transition metal or metal ion has 1 or more unpaired electrons, it is attracted by the magnet and it is paramagnetic in nature. If it doesn't have unpaired electrons, or if it has empty d orbital, it is repelled by the magnet and it is diamagnetic in nature. And transition metal ion in its highest oxidation state do not have d electrons. Usually it is diamagnetic in nature. If the transition metal ion is in lower oxidation state, it can have unpaired electrons and it can be a paramagnetic substance. Based on this concept, let us look at these 2 questions now. The question is, which of the following is diamagnetic? Options are nickel 2 plus, chromium 2 plus, cobalt 3 plus, titanium 4 plus. As said, if a transition metal ion is in highest oxidation state, it can lose all the d electrons and exhibit the highest oxidation state, and it doesn't have unpaired electrons. When it doesn't have unpaired electrons, it behaves as a diamagnetic substance. Look at the given options. Nickel 2 plus has unpaired electrons, chromium 2 plus also has unpaired electrons, cobalt 3 plus also has unpaired electrons. Nickel 2 plus, chromium 2 plus, cobalt 3 plus with 1 or more unpaired electrons exhibit paramagnetic property, therefore they are not diamagnetic. While titanium 4 plus, which is in its highest oxidation state, do not have d electrons. So therefore titanium in plus 4 oxidation with no d electrons is repelled by the magnet and it is diamagnetic in nature. So the correct option for this question is titanium 4 plus, option D.